Wednesday, huwag mag-absent. At sa Thursday, huwag kakalimutan ang attendance. Miss Dubu. Okay? So, yun yung importanteng dates na alalahanin natin. Hindi pa rin nag-explain. So, yun yung ayan. So, yun yung dates natin. So, again, October 10 will be your first exam. And then, Thursday this week, so, October 3, 4. So, October 5, you will submit your book. Okay? Good. So, today we will talk about static equilibrium. So, we have learned the concept of torque, center of mass, and center of gravity last week. Okay? So, for today, we will continue our discussion on those topics, but let us see the implication of those concepts with respect to the rotational and static equilibrium. Okay, so let us have a review. Sabi nila, sikat daw sa TikTok yung Vans na sapatos, yung skateboard, yung Vans. Sabi nila kapag hindi ko na-save yung YouTube, pinapanood ko kanina. Kapag binagay-bag mo daw yung Vans na shoes, lagi siyang mag-stand upright. Napanood niyo na ba yun sa TikTok? May TikTok ba kayo? Wala kayo, gano'n? Pareho tayo lang ng TikTok. But anyway, sige, hahanapin ko na lang and then I will show you tomorrow yung YouTube post na yun. Okay? So that has something to do with the concept of stability and center of gravity. Okay, so we will talk more about the concept of Vans shoes standing upright, always with stability and center of gravity tomorrow. Kapag nakita ko yung video, okay, ipapakita ko siya sa inyo bukas. Okay? But, okay, so we have learned the concept of stability last week. So, lower center of gravity meaning and larger area of support, meaning the object is more stable. And of course, the concept of center of gravity is used by tightrope walkers. Okay, and then they use a long stick to compensate for the change in their center of gravity when they step sa rope. Okay, when they try to balance their hello. Siguro ito dapat masyadong balance. So, in translational motion, we have the concept of equilibrium, the translational equilibrium via Newton's laws of motion. So, this is the same as the first law of motion. Okay, so try kong pumunta dito ha. Okay. So, in translational motion, we can say translational equilibrium. Translational equilibrium means that the net force along the x, y, and z are all equal to 0. So ito yung net force is equal to 0. Newton's first law of inertia. Okay? In rotational equilibrium, so what does it mean to have a translational equilibrium? It means that you have no acceleration. Okay, it means you have no unbalanced forces along the x, y, and z plane. Okay, so in rotational motion, we have what we call the rotational equilibrium. And the rotational equilibrium states that the object is in equilibrium rotationally when the net torque is equal to 0. And when the net torque is equal to 0 about any pivot point, about any rotational axis, then that means you have no angular acceleration. So here, this means no rotational acceleration. This means no angular acceleration. Okay, so ibig sabihin na to, no unbalanced or no net torque should be equal to zero, meaning there is no unbalanced torques. So no unbalanced torques. Okay? So no unbalanced torques, meaning you can have an object, an equatable object. So this could equal in this axis of rotation. So I have a stick here, and this can rotate clockwise or counterclockwise. So when I say that net torque is equal to zero, it does not necessarily mean na walang torque na nag-exist. It's just that yung torque na nag-exist to move this clockwise will counter by the torque that exists moving this counterclockwise. Okay? So, ibig sabihin kung meron akong torque na binibigay ng force. So, this force or torque will move this clockwise or counterclockwise. So, ibig sabihin, ibabalot siya ng torque na mag-move ng counterclockwise. So, kung paganyan siya, yung torque, I have another torque represented by this force. Okay? So, when you calculate the torque, so this is L, this is L, net torque is equal to F times L minus F times L equal to 0. So, net torque equal to 0 does not necessarily mean no torque is acting on the object. Ibig sabihin, yung clockwise and counterclockwise rotation, nababalance siya ng mga torque na nag-exist acting on the object. Okay? So those are the conditions for equilibrium. Okay? So, this also means that when you have no net torque, that means because torque is the tendency to rotate, then no torque or net torque is equal to 0 means no rotation. Okay? So no angular acceleration. Kapag net force is equal to 0, acceleration is equal to 0. 0 means angular acceleration is equal to 0. Okay? So now let us imagine this example. Hello? There. Okay. Hello? Ayan. Rinig niyo pa rin ako, okay? Sige, dito naman lang ako sa tabi. Hindi na pupunta doon. Okay. So, now let us consider the following examples. Let us take a look at the conditions for the translational and rotational equilibrium are satisfied. Okay, so the first condition is the translational equilibrium. The second condition is the rotational equilibrium. Okay? So let us take a look at this first example. So in this first example, somewhat similar to this one, diba? So here, first condition, satisfied ba siya? Yes, because when you add the forces upward and downward, net force is equal to 0, right? Yung upward force F and then yung downward force F, it is equal to 0. Okay? And how about the second condition? If you calculate the second condition, you will have net torque and then net torque na pareho siyang papunta negative. Okay? Into the page. So you have a net torque, therefore net torque is not equal to 0. So this example is translational equilibrium. Good? Okay? So again, we are looking at two conditions. The first condition is translational equilibrium. The second condition is rotational equilibrium. So in this first example, we can see that translational equilibrium is satisfied, but the rotational equilibrium is not satisfied. So here, we can say that, okay, this object is not accelerating upward or downward, but it will rotate clockwise because of a net force. Okay? Second example. So, here in the second example, obvious na agad, di ba? Obvious na agad na yung first condition ay hindi satisfied, right? Because you have a net force upward which is equal to 3F. Di ba? So, the net force is equal to 3F. Therefore, this figure here is not in translational equilibrium. What about the second condition? Is it in rotational equilibrium? Let us see. Tingnan natin, force upward, and then 1/2 L upward to F. So we can see that FL plus 2F times 1/2 L, this is equal to 0. So the net torque is equal to 0. Okay? So this example over here is rotational equilibrium. Okay? Next. Here we have the first condition satisfied because we have 2F upward and 2F downward. Therefore, 2F minus 2F is equal to 0. So the first condition or the translational equilibrium is satisfied. Okay? How about the second condition? So the second condition is also satisfied because FL minus FL is equal to 0. Okay, so therefore here, no net torque also exists at this point. Okay? So when the first and second condition of the equilibrium are satisfied, we say that this example over here is in static equilibrium. Okay? Again, kapag the net force is equal to 0 na, ang ibig sabihin nun, the body is in translational equilibrium. If net torque is equal to 0, that means that the object or the body is in rotational equilibrium. When both the first and condition are satisfied, when net force is equal to 0 and the net torque is also equal to 0, then we can say that this object is in static equilibrium. Ano yung sabihin ng static equilibrium? Yung sabihin, ano yung sabihin ng static? Hindi gumagalaw, hindi siya at rest. So, if this starts from at rest, it will not accelerate rotationally and translationally. Therefore, it stays at rest. Kaya siya static. Okay? So again, pag net force lang, translational. Pag net torque lang yung 0, rotational. Kapag parehong net force and net torque, starting from rest, it is static equilibrium. So dapat at rest. At rest, net force is 0, net torque is 0. Then this object is in the state of static equilibrium. Okay? Okay, so again, take note na yung net torque is equal to 0 is the same as saying that the torques producing the clockwise rotation is equal to the torques that producing counterclockwise rotation. Okay, same lang yan. Kasi nagbabago lang naman yung sign kapag clockwise or counterclockwise yung nagiging effect ng torque. Diba? So let us take a look at another example. The girl-boy system in a seesaw is in static equilibrium. Show that the force due to girl, so this girl and boy balances each other. So let us take a look. The torque because of the girl is 200 newtons multiplied by 3 meters, so counterclockwise that is positive. And here we have 400 newtons times 1.5 meters, so that is clockwise, so the torque is negative. Okay, so when we calculate that, the counterclockwise torque is 600 newton meter, the clockwise torque is also 600 newton meter, therefore they balance each other out. Okay, so the net torque therefore is equal to 0. And when we draw the free body diagram, you will have to take note of the length, yung moment arm. Because because of the torque caused by the weight of the buoy and the girl. Okay? Another example. Consider a 2 Newton uniform meter stake. So this is a meter stake. And then 2 Newton yung kanyang weight. And then the meter stake is hung at its center. Two masses, 10 centimeter, at 10 centimeter and 80 centimeter mark, are attached to the beam. And the beam is in stable or static equilibrium. So number one, let us draw the free body diagram. Number two, let us calculate for the weight hung at the 10 centimeter mark. And number three, let us calculate for the tension at the 50 centimeter mark. Okay? So how do we draw the free body diagram of this object? So again, it is important to note the moment arm. Okay? So therefore, when we draw the free body diagram, when we draw the free body diagram, we should draw the extended length of the meter stick. So meter stick, ibig sabihin the length is 1 meter. Okay? So sabi, nandun sa center ng ang so therefore, tension is at the center, and then the weight of the beam is also at its center of mass or center of gravity. Right? And then we have here the forces for the 10 centimeter mark and the forces for the 10 centimeter and 80 centimeter mark. Okay? So now let us use the second condition of equilibrium to solve the problem. So we know that the body or the system is in static equilibrium. Therefore, the net torque is equal to 0. Okay? And the torque that causes the clockwise and counterclockwise rotation are equal to each other. Okay? So therefore, the force that causes the counterclockwise rotation, so this one, multiplied by the distance, here the moment arm is 40 centimeters, should be equal to the force that causes the clockwise rotation, so that's 20 newtons, multiplied by the moment arm, in this case, that is 30 centimeters. Okay? So we have force counterclockwise is equal to force clockwise multiplied by dCW, so that's 30. And then dCCW, that's 40. So 20 times 30 divided by 40, you will get 15 newtons. So the weight of the block hanging in this 10 centimeter mark is equivalent to 15 newtons. Okay? So now that we know what is the total weight of the two blocks and the weight of the beam, we can calculate for the tension. We will use the first condition. So the first condition states that the net force along the y component should be equal to 0. So therefore the tension should be equal to the weight of the beam plus the weight of the two blocks. So that's equal to 20 plus 15. And then the weight of the beam is, the weight of the beam is 2 newtons. So the total is 37 newtons. Okay, so that is how we use the concept of static equilibrium to solve this problem. Okay? Next example. So in this next example, a 50 Newton bar. No. 50 Newton bar. So this bar here is 50 newtons yung kanyang weight. 50 Newton uniform bar rests on a frictionless wall as shown. If the bar has length 2 meters and the angle it makes with the horizontal floor is 60 degrees, what is the minimum coefficient of static friction needed so that the bar will remain at rest? So ibig sabihin, this bar is also in state of static equilibrium, meaning the net torque acting on the bar is equal to 0 and the net forces acting on the bar is also equal to 0. Okay? So let us start with the free body diagram of the situation. So this is the free body diagram of the situation. So we have the weight of the beam. The weight of the beam will be from the center of mass. So let us assume this is the center or the middle of the beam, okay, the bar. And then what do we have here? We have the normal force because of the wall, the normal force because of the floor, and the frictional force. Kasi gusto na natin mag-calculate yung coefficient of static friction. Okay? And then we have here the angle. So because we know the angle and then we know the length of the bar, we can use Pythagorean theorem to calculate for the moment arc. Diba? So using the first condition, we have net force along the x should be equal to 0. Therefore, normal force ng wall plus static frictional force should be equal to 0. Diba? Yan yung net force along the x component. How about the net force along the y component? The net force along the y component, we have the weight of the bar and the normal force of the floor. So normal force of the floor minus weight of the bar is equal to 0. So these are the equations for the net force. Okay? How about the Fs? Ano yung sabihin ng Fs? Fs is the static frictional force, which is equal to coefficient of static friction multiplied by the normal force. Pero ano yung normal force na gagamitin natin? Normal force ng wall or normal force ng floor? That's correct. Normal force ng floor. So mu so Fs is equal to mu s times n ng floor. Okay? So crucial yan class ha, na yung normal force na gagamitin natin for Fs is this one, not this. Okay? So here, if this is our equation, then mu s is equal to Fs over n floor. And looking at the equation of motion earlier, we can see that Fs is equal to n wall and n floor is equal to W bar. Okay? So meron na tayong equation for mu s. Paano natin na-calculate yung n wall? Yung W bar, given na siya, diba? Given na siya ng 50 newtons. Pero itong n wall, paano natin ito-calculate? We can calculate this using the second condition of static equilibrium. Net torque should be equal to 0. So ang gagawin natin, we will choose this lower end as the pivot point, and we will calculate the net torque to get n W. So ang sabi sa second law, because this is in static equilibrium, therefore the net torque acting on the bar is equal to 0. So therefore, yung torque because of the weight of the bar plus torque because of the normal force of the wall should be equal to 0. So here in this calculation, WB is this one, and then NW is this one. Okay, so net torque is equal to 0, therefore W torque because of the weight and torque because of the normal force of the wall is equal to 0. So what are these torques? So because of the bar, we have, so this is 60, so kung kukuha kayo ng triangle dyan, 60, and then therefore this is 30 degrees. Kasi 90 minus 60 ay 30. So this is 30. Okay, so sine 30, and this is 2 meters, so therefore 1 na lang siya. So 1 meter times 50, which is the weight, and then sine 30, that is the torque because of the weight of the bar. How about the torque because of the normal force of the wall? So of course, this is negative because it produces clockwise rotation. Okay? So 2 meters, okay, multiplied by, ano yung angle na to? So if this is 60 din to, right? Diba? So, pareho lang sila. So, sine 60 times 2 meters, sorry, nakalimutan ko mag-m. Dapat may 2m yan. 2 meters times sine 60 multiplied by n wall. And we have here an equation, only one unknown, n wall. So, you can calculate n wall as 14.4 newtons. And then after that, you will substitute this value to our equation earlier. Therefore, mu s is equal to 14.4 or 14.43 divided by 50, which is the weight of the bar, and therefore the coefficient of static friction is 0.289. Okay, dimension is kasi coefficient of static. Good? Sorry, hindi na ako makapunta doon kasi chubby net force should be equal to 0. Second condition, net torque should be equal to 0. Third condition, dapat at rest. Kasi static. Okay? Assignment. Parang ang bilis ng lecture na alam ko. Baka pwede na natin itong i-check ngayon. Okay na. Wait. Ito yung assignment pala natin last meeting. Okay? Correct? Ganito na lang. Check na lang muna natin yung assignment natin last meeting. And then I will have other announcements. Okay? Correct? Tama ba? Ito yung assignment natin last meeting. Correct? Okay, sige. So let us check. Please exchange blue books with your classmates. Okay, exchange blue books with your classmates na. Okay? The answer for number 1 is 0.65 kilometers. Sandali, yung given ko ay 2 kilogram. Okay, 2 kilograms pala yung given, tapos 1 kilogram to. So, you have to multiply. So, dapat 2 kilograms pala. Okay, ginagawa ko pala yung given. Pero 2 kilograms yung binigay yung given sa ano. Okay. Okay, so binago ko din yung given. So, this should be 1.3. Okay, sige. So, this should be 2 kilograms. Binago ko na naman yung given. Okay, this should be 1.3. And then the other one should be at the edge of the sphere, so you will do parallel student. This should be 2 kilograms. And this, ano dapat yung put dito? So, go na siya up. So that's the big 2.8. Okay, 1.3 and 2.8 kilograms per square. Okay? Okay, and then finally we have the receipt. Okay? And then this is the assignment for the day. Hello? Yeah. Dalawang items, okay? Ha? This one? So, 2 questions yung assignment. Ha? Next na. Okay. And then, i-repeat slides sa mga gusto mag-picture o mag-video ng lecture slides. Okay? Okay, I will replay yung slides natin. Okay? Game na, ready na? Hello. Okay, I will So again,